So what is the first thing we need to do if we are going to do a completely randomized design? Yes.
We're going to assign 1 through 50 to each student.
Yes. Label the chosen students 1 to 50. After we've labeled our students from 1 to 50, what are we going to do?
Use a random number generator to select 25 students.
Close. What'd you say, Soha?
25 students out from numbers.
Oh.
We're going to select 25 numbers, okay. Random number generator. And I know it seems pedantic, but they get picky about it, which is why I'm making sure to slow us down and make us do that step. Random number generator can only pick out numbers. What's important about those 25 numbers?
They're all unique.
They're all unique. They're non-repeating because we don't want to pick the same student twice. So use a random number generator to select 25 unique numbers between 1 and 50. We have to give the lower and the upper boundaries here as well. So we label the students 1 to 50. We use the random number generator with numbers between 1 and 50 to select 25 unique or 25 non-repeating numbers. Okay, so now we have 25 numbers.
Corresponding students will take classes online.
All right. Assign the students corresponding to the chosen numbers to the online SAT prep class. Would it have been wrong at this point to say assign the students corresponding to the chosen numbers to the classroom teacher SAT prep class? No, but you have to pick one. You can't just say assign them to one of the groups. Pick one. Make a decision. After we have assigned these 25 students to the online SAT prep class, what do we do?
The remaining kids will take the class in person. Is that right?
Yep, assign the remaining students to the classroom teacher SAT prep class. Yes. All right. Yes. Yes. We do have one very last step. So far, all we've done is set up the experiment. But if we're going to have a completely randomized design here, we got to talk about the end. At the conclusion of the prep classes, have all the students take the SAT and compare the scores between the two groups. Yes?
I could have the students take the SAT after a month. Is that fine?
That'd be fine.
Okay.
Yeah. That'd be fine. The point is, after the conclusion of this thing, whether it's a month-long class or 6-month, I have no idea how long SAT prep classes are, and it didn't say up here. This is a completely randomized design. Completely randomized design. Yes, David?
So, I was going to ask, so why don't you put, because for yesterday, I remember the problems you put, it's like you have a classroom and then you put like an online and then you put like a conclusion. Is that what that?
What do you mean?
Like showing the two choices, like you would put, showing us to assign those students to SAT prep class and then that you assign the other 25 to.
It's right here. That's okay. That's okay. You just didn't see that stuff. Yes. We have to assign every person that is part of this study. When you get to the end of writing your completely randomized design, go back and check that every person that was involved, those 1 through 50, have been assigned somewhere. You don't want to have a group just sitting off to the side. It will not just be understood that they go to the other group. You have to clearly state that. Yes.
Okay. I know I kind of asked this before whenever I said it, but because we can't make assumptions in this, I did say in-person, in-person class. Would that mark me off points instead of saying classroom teacher?
I don't believe so. No. The classroom teacher would be the in-person. If they're making a point between online and classroom teacher, that would be online and in-person. I think that would be okay. Did you have a question, Jamie? Did you have a question? Okay. Yes.
So if this is on a test that you didn't put the last part at the conclusion, will it still matter on that?
Yes, it would. Yes. So we've been asked similar questions. Sometimes we've been asked how to randomize between our two treatments. If you are just asked how to assign them to two treatments, you can leave this last part out. But if you are asked for a design for the experiment, then you have to include this last piece where you compare at the end. Do you guys have any other questions about number 1? These are great questions.
Why is the science like that?
I have no idea.
So natural.
All right, let's go down and look at number 2 now. Of the 50 students that signed up for the prep course, 30 are juniors and 20 are seniors. The counselors are worried that the random assignment could potentially put all the seniors into one of the treatment groups. Why would that be a problem? What'd you say? There is more juniors, but why is that a problem?
It's not, it could add like a confounding variable and like,
What would our confounding variable be here?
grade.
Grade. Why could that be confounding? If it's a confounding variable, we should be able to relate it to the explanatory and the response. What's our explanatory variable here? Yep, type of prep class taken. What's the response variable? Scores. Okay, so obviously we have a connection between grade level and which class they're taking. If they all end up assigned to the same class, we have that connection. How is that connected to scores, though? How could their grade...
The seniors.
Because like usually you have to take the SAT junior year, so like the seniors probably this is their second time, so they're trying to get a better score. So
trying to get a better score. They've seen this once before. They've been through the testing experience once before.
They've been in more classes. They could know more stuff.
They've taken more classes. They know more stuff. They've been exposed to this. What we've seen is that if you take the SAT more than once, typically you do better each time. So yes, this could be a confounding variable here. If this treatment group that all the seniors get assigned to ends up with higher SAT scores, we wouldn't know if it was because of the type of prep course or because it was full of seniors. Remember, we want to try to determine cause and effect with an experiment, but if I have this confounding variable in here and all of my seniors end up in the same group, I'm not going to know what the true cause of those higher scores is. So, how could we adjust our experiment to eliminate this potential problem? Describe an experiment with your modifications. I think your page says draw again. We're going to describe.
Couldn't you do like
Yes. So let's talk about exactly how we do that. The comment was we're going to have 15 juniors and 10 seniors in each group so that we are controlling for this variable of which grade level they're in. So the first thing we do, if we want to make sure that we have 15 juniors and 10 seniors in each group, we start by dividing the participants into juniors and seniors. This feels like stratified sampling, but it's not. Stratified sampling is how we get the people that are going to be involved. Here we already have the people that are involved, but we break them into homogeneous groups. We break them into groups. These groups are called blocks in this type of experimental design. So we have a block of all juniors and a block of all seniors. All right, we're going to describe the process for one, and then we'll describe the process for the other. So let's look at the seniors first. We're going to label our seniors from 1 to 20. We're going to use a random number generator to select 10 unique numbers between 1 and 20. And then we will assign those seniors to the online SAT prep class. So I've got 10 people in my online SAT prep class. What would I want to do now?
do this?
Juniors.
Yep, do the same thing for the juniors, except juniors I'm not going to label 1 to 20. I'm going to label them 1 to 30. And then my RNG is going to choose 15 numbers between 1 and 30. And we will assign those to the online SAT prep class as well. So now I have 25 people in the online SAT prep class, 10 seniors, 15 juniors. Now what?
Put the rest of them in the in-person class?
Yes. Assign all remaining students, juniors and seniors, to the classroom teacher SAT prep class. Okay, so now I have 25 people in my online SAT prep class, made up of 10 seniors and 15 juniors. I have 25 people in my classroom teacher-led SAT prep class, made up of 10 seniors and 15 juniors. Now that everybody is in their assigned classes, what do I do? Conduct the experiment. And what do I do at the conclusion of the experiment? Yes. So very last step, squeezed in way down here at the bottom, compare the results within the groups and between the groups. And I want to talk about that for just a moment. So I can compare the seniors that did the online class to the seniors that did the in-person class. I can compare their scores within one block. I can compare juniors to juniors, because maybe the in-person class is better for the juniors, but the online class is better for the seniors. I'm going to be able to make this determination because I broke them out into blocks first. And then I can also just compare the two big categories. I can compare seniors to juniors. I compare online to in-person. So I want to compare within the groups and between the groups. This is called a block design. This is called a block design. Is what grade somebody is in the only factor that we might want to think about as far as why somebody might do better on the SAT? What else could have an impact on this? What'd you say? Type of classes you're taking? Whether or not you've taken the SAT before? Prior SAT courses they may have taken or extra studying that they may have done. Hold on just a second. I'm going to dig a little bit deeper into your comment. How's a way we could quantify that? What'd you say? We could look at GPA, right? If somebody has a 4-point and somebody else has a 1.5, who would you expect to do better on the SAT? Probably our 4.0. If they both took prep classes, if they both took an SAT prep class, let's say our 4.0 took the online prep class and the 1.5 took the in-person prep class, are you going to be able to make a determination about whether it's the prep class or not? Not really. So let's look at another possible way of dealing with this problem. The counselors are also worried that the random assignment could potentially put all of the super hardworking, the high GPA students into one of the treatment groups. They have a list of the 50 students and their GPA ranked from highest to lowest. How can they use this list to help them set up the experiment? So what if we took our top 2 GPA students, the top 2, whether they're juniors, whether they're seniors, whether it's one of each. We're going to take the 2 students with the highest GPA, we're going to match them together. We're going to make a pair here. And then in that pair, I'll flip a coin. If it lands on heads, person A takes the online class, person B takes the in-person. If it lands on tails, person A takes the in-person, person B takes the online. And then I could match up my next 2 highest GPAs, person 3 and 4. And I could do this random assignment again, flip a coin to send them to the 2 classes. And then person 5 and 6 matched up, like the next 2 and the next 2 and the next 2. Would I still end up with 25 people in each group? Yes. Would they still be randomly assigned? Yes, I'm using a chance device. My coin would be my chance device.
But then wouldn't that just displace the grade levels? Like, couldn't it be different? Like more seniors in one group?
We could. We could still end up with more seniors in one group than juniors. Like more seniors, all the seniors in one group. This wouldn't be controlling for that particular aspect. This would be controlling for GPA. So we'd be controlling for a different, potentially confounding variable. Yes?
You can do both at the same time, though, right?
We could do both at the same time, yes. It would make it more complicated, but yes, you could control for both of those confounding variables at the same time. Pair the top 2 students, then the next 2 students, and so on, so that we end up with 25 pairs. For each pair, flip a coin. If it lands on heads, the first student in the pair gets the online course, the other would get the teacher prep course. This is really important that you talk about what happens to both people if the coin lands on heads. But just as important, you have to talk about what happens if the coin lands on tails. So if the coin lands on heads, you have to assign both people. Make a decision. Assign them to their groups. If it lands on tails, you make the opposite assignment. But you have to explicitly and clearly state this. You cannot leave any of this up for the imagination. And then we do have to clarify this. I can't just say the first person or the second person. I have to come up with what I mean by first and second. In this case, I'm going to say the first student in the pair is the one whose last name comes first in the alphabet. I have to explain what I mean by the first student and the second student.
Could we also say the first student could be the one with the higher GPA?
The problem is going to be, what if you have 2 people with 4.0s?
Okay. What if they both have the same last name?
If they both have the same last name, then you move on to first name. If they both have the same first name, then you move on to middle name. If they have the same first, middle, and last name, I don't know if there's anybody at this school that has same first, middle, and last. Then you could do that. We can get really pedantic with this. We can go into insane amounts of detail and look at all of the possible what-ifs. I don't think you need to dig that deep into it, but I do think you need to clarify, if you're going to talk about a first student and a second student, what do you mean by that? I have seen, this by the way is called a matched pairs design. This is called a matched pairs design. Those of you that have taken AP Psych, or even if you haven't taken AP Psych, have you ever heard of a twin study before? Yeah. Twin studies are matched pairs designs. With matched pairs, you want to put 2 things or 2 people together that are as identical as possible. And then you will randomly assign to your 2 treatment conditions. With twin studies, because one twin has always been born first and the other twin was always born second, you could say, like, the first person in the pair is the twin that was born first. and the second person in the pair was the twin that was born second. Something like that. We want to be as clear in our communication as we possibly can, so there is nowhere in this recipe that somebody is going to be reading through it and go, wait, what do I do with these people over here? Or how do I make this decision? All of the decisions should already be made. Your description should make all of the important decisions for whoever is going to actually run this experiment. A matched pairs design works like block design, but our blocks are only of size 2, and we have lots of blocks. Yes. Restroom? Yes. Audrey? Do you still have my pass?
I gave it back.
You gave it back? It didn't end up back over here. Okay. David. All right, are you guys ready to take this over onto the back side? Write your name, date, and time on there, and then marker goes here. All right, let's flip this over. Page 22. Block design. A block is a group of experimental units that are similar. A block is a group of experimental units that are similar. Again, this feels a lot like stratified random sampling. But with stratified random sampling, that is how we get the people that are going to be involved. Here we already have everybody that's going to be involved. And we're going to split them into blocks so that we can randomly assign them to the treatments within each block. So we will equally divide the blocks between the treatment conditions. In a matched pairs design, subjects are paired. We have blocks of size 2, and then randomly assigned to a treatment. One person from each pair or one item from each pair would get assigned to the different treatment conditions. Another way that you can do a matched pairs design is if each subject receives the 2 treatments. Each subject receives the 2 treatments with the order of the treatments randomized. Do you guys remember yesterday when we were looking at the athletic trainer that had the strength building workout and the relaxed workout? So we could do a matched pairs design like this by saying, okay, we're going to randomly assign the athletes to get one of the 2 exercise workouts. And then after 2 weeks, we'll test them, see where they're at. We'll give them a week washout. And then they're going to do the other workout so that everybody would get exposed to both treatment conditions. That's another way of doing a matched pairs design, where a person would be paired with themselves. Or another one that I heard that I really liked is construction workers. If they're trying to test out a new type of work boot, you could flip a coin. If it lands on heads, then on the right foot they wear the new work boot, and on the left foot they wear the old brand. If it lands on tails, then on the right foot they wear the old brand, on the left foot they wear the new brand. So they are matched with themselves. That way both boots are going to go through the exact same conditions. And we could see at the end what happens, which one stood up better to the construction work. Does that make sense? So matched pairs, we can either match 2 people or 2 items together, or we can match a person with themselves, and they will experience both of the treatment conditions. All right. Check your understanding. Your directions, I believe, say to outline. You're going to just describe again. Describe a completely randomized design to compare the effectiveness of the 3 advertisements that are described up here. A political strategist would like to design an experiment to compare the effectiveness of 3 different YouTube advertisements promoting a specific presidential candidate. She will use 300 randomly selected YouTube users for the experiment. Start off with just a randomized design. Give me a randomized design for this.
Miss Wong,
Yes.
they don't specify the groups. What do we do in that case?
What do you mean? For number 1?
Yeah, they don't say like this treatment, that treatment, third treatment. They just say that promoting a specific presidential candidate. Do we say presidential candidate number 1, presidential candidate number 2?
You could do 1, 2, and 3, or you could do A, B, and C. Yes. Since they don't put names with them, you need to find ways of describing the differences between them. All right, let's talk about this one. What's the first thing we want to do? Label. Label what? Yes. Label the 300 selected YouTube users, sorry, not YouTubers, YouTube users, with a unique number from 1 to 300. What do we do then?
Use an RNG to select 100 unique numbers between 1 and 300.
Yep, use an RNG to select 100 unique numbers between 1 and 300. What are we going to do with those 100 numbers?
The corresponding users will be given advertisements from
Love it. Assign the people corresponding to the selected numbers to see ads for candidate A, or you could call it candidate 1, or you could say the first candidate, or whatever. All right. Then what?
Repeat the process to select 100 different users for candidate B.
Yes, I think I broke mine down into 2 steps. Yep. I said relabel the remaining 200 people with a unique number from 1 to 200. That is repeating that process. And then use an RNG to select 100 unique numbers between 1 and 200. If you said repeat this process to select 100 different people, that would be sufficient. All right. We're going to assign those people to see the ads for candidate B. Thank you, David. So far, we have 200 people assigned. What do I do now?
The remaining users will be advertised.
Yes. Assign all remaining people to see the ads for candidate C.
Have them vote.
Yep. At the conclusion of the experiment, whatever that happens to be, compare the effectiveness of the 3 ads between the groups. With the description they gave me up above, I don't know exactly what they're using to evaluate the effectiveness. Typically, we're going to be told what they're using to evaluate the effectiveness with, and we would want to talk about that here. You doing all right, Lyric? All right. Number 2. I want you to write out a description of a randomized block design for this experiment. Justify your choice of blocks. So let's talk about this one rather than just setting you loose on this one. What do you think might impact voting habits? Yes.
Party affiliation?
Political party affiliation. Absolutely, you could do that. Yes.
Age.
We could use age, which is actually the one that I chose, but you could absolutely go with political party affiliation. Is there anything else that you could think of other than age or political party? Yes.
Economic status?
Economic status.
It's kind of hard to know, but whether or not they're paying attention to the YouTube video, because like depending on if it's a visual ad, like someone could be listening to a podcast. You know how on YouTube Premium you can turn off your phone and still watch the video, and the ad wouldn't be as effective.
Yes. Yeah. So that one, what they might be able to do is one of the things that they can record is like whether or not there's mouse movement. So we could determine like how engaged are they with the videos that are playing. There are lots of different ways we could go with blocks here. I decided to go with age. So I said divide the 300 participants into 2 groups of 150 each by age. Or you could say divide the participants by political party affiliation. If you did that, you would have to state what the political party affiliations are that you're using. So like Republican, Democrat, Independent. Once I have them split into their blocks, what do I want to do? Once they've been split into their blocks.
Use the random number generator to assign 1 through 150 for each block.
We're going to label, in this case, I'm going to label my 150 older participants with a unique number from 1 to 150. And then we will use the RNG to select 50 unique numbers between 1 and 150. Why would I only select 50 numbers? Because I have 3 different advertisements. So I need 50, 50, and 50. Assign the corresponding people to see ads for candidate A. Relabel the remaining 100 older participants from 1 to 100. Use an RNG to select 50 unique numbers from 1 to 100. Assign those corresponding people to see ads for candidate B. Assign all the remaining older participants to see ads for candidate C. So now I took one of my blocks and I've divided them between the 3 treatment conditions. What do I still need to do? Yep. Now I need to do the younger participants. And this one I can get away with because I went into so much detail about talking about how I'm splitting up the older participants. I can just say repeat the process to assign the younger participants to the 3 treatment groups. And then at the conclusion of the experiment, compare the effectiveness of the ads within each block, and then combine and compare the results for the whole group. So within the older participants, I would look at effectiveness for candidate A, B, and C ads. Within the younger participants, I would look at the effectiveness for the ads for candidates A, B, and C. And then I would put the whole thing together and compare the effectiveness for the ads for candidate A, B, and C between these 2 blocks. So we will compare within the blocks and between the blocks. The question also said to justify your choice of blocks. So off to the side, because I didn't have room, I wrote, I chose age for blocks because ads affect young people differently. Or you could say ads affect older people differently, which is definitely true. Speaking of, y'all, my mom almost got scammed on Facebook over the weekend. $1,000.
Why? Like, how was the scam?
They were selling a car. Somebody had hacked her friend's Facebook page and was selling a car for like, I don't know, $10,000 less than it's worth. So she was like, I'm interested. I'm going to go check this out. And they're like, well, you can come see it this weekend, but we need $1,000 to hold it for you. And my mom never actually texted her friend. She just communicated through Facebook. She got all the way to sending the money through Zelle, and the bank stopped it. So now I have to have a talk with my mom about internet safety.
I'm surprised for how big Facebook is. Its security isn't like insane.
It is horrible.
I know
It is a
it's-
free-for-all.
But like,
It's not hard.
If
If
you
you
don't
don't care about your users, would you really expect them to stay?
They do.
They do, but it'd be better if they were better. I don't assume that their goal is just not to care.
I assume a hacker would just some way find a way to get over it.
I like the
Yeah.
logo.
$0 for
$200,000.
I like dropped their price by $1,000 to see what they say. Or depends on what you're selling.
Right. Yep.
What is this? She's like, oh,
Got it off Facebook Marketplace. Yeah. And like, that can be a decent way to get stuff. But be careful and never send money before you're in person with someone. Like,
I think that's the key fact, like the key word, where send me money first, so hold it like a deposit.
right? Like, nope, 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 nope.
Is it because older people are more trusting? Is that why they get scammed?
So, my mother-in-law has worked like in home health care and around nursing homes and stuff for a while, and they have a doctor that comes in and talks to the families about what happens as you age. But the critical thinking skills that allow you to reason through stuff start to break down as dementia sets in. And so, and some of the things that you were taught when you're very young are the things that stick with you when you're older. And so, like, a lot of children are very trusting. Older adults tend to be too trusting. All right, last thing up here. Why might a randomized block design be preferable in this context? Why might a randomized block design be preferable in this context?
Is it not just older people are more likely to be susceptible to ads?
Older people are more likely to be susceptible to ads.
That's a big word.
So in that case, age would be a what? Confounding variable. The block design helps to control for age as a confounding variable. Within each block, there will be lower variability of results, making it easier to determine which ad is most effective. So just like when we do the sampling methods, stratified random sampling had lower variability. This block design is going to have lower variability within the blocks, and then I can compare between my two blocks as well. Maybe the ad for candidate A was more effective with the older people, but the ad for candidate B was more effective with the younger people. I'm not going to be able to see that distinction if I don't control for age, if I just have everybody all mixed together. Yes.
When do you know when to pair and when not to? Like the last one we paired for blocks, but this one we didn't.
So the last one we did both types. We did blocks, one of juniors, one of seniors, and then we also talked about how to do a matched pairs design. Okay. When would you know as an experimenter or as a researcher? So I guess what we'd be looking at is, do I have like groups that are fairly similar that all go along with like a variable that I'm concerned about? In this case, like on the previous page, we were looking at what grade they're in. And so we have this similarity between our two groups. And we think that that is going to be like the big influencing factor here, is what grade they're in. In a matched pairs, you're going to put two pieces together that are as identical as possible. Looking at the AP exam, if they want you to use one design over another, they will tell you. They will tell you. In the real world, it gets a little bit trickier. In the real world, you just kind of have to look at like what situation am I looking at here, and what type of design would work best. So you would want to try to identify confounding variables, if at all possible, on the front end. And sometimes the best way to control for those is going to be with a matched pairs design. Like with the work boots example that I used for matched pairs. Maybe I have 25 people that are all in construction, but some people do like inside of house construction and other people are working on big commercial high-rise buildings. Those boots are going to be put through very different conditions. And if I end up with all the people that do like inside of home repairs, they all end up with the new work boots. And the people on the high-rise construction sites are all wearing the older brand of work boots. It's going to be hard to tell whether it was the conditions that they were put through or whether it was the boots. So on that one, I would want to do matched pairs, because for each person, I can put both boots through the same treatment condition, or through the same conditions with both of my treatments.
So you kind of have to logic your way through it.
You have to logic your way through it. And sometimes Like sometimes matched pairs would be better, sometimes block design would be better. Sometimes it's kind of a toss-up as far as which one would be better, and you just have to make a determination at that point. Yes.